So what I want to talk about is AI and the climate challenge. What is the climate challenge? What do we mean by it? So very quickly, and some of you might have seen this before. So this is essentially an overview of how the climate system has changed in deep time, with data from 60 million years ago up to now. And as you can see, of course, climate has changed, and there have been shifts in the way the climate system has operated. But we also need to recognize that sometime 10,000 years ago, something very unusual happened, and that was the Holocene, a very stable state in the climate system starting 10,000 years ago, where you didn't see as many rapid shifts in the climate. And this is essentially when civilization started to blossom. This is where we created technologies, democracy, culture, agriculture, etc., etc. Now, of course, what's happening now due to climate change is that we're moving very, very quickly outside of that stability domain, as we call it. And that poses massive, massive challenges. We have created our societies, very complex societies, around that stable state, but now we're moving outside of that. And what does it mean? I mean, the only thing we know now is that these changes are happening quickly. We're seeing that now already, and they will impact on everything we see. So whenever we talk about the climate challenge, it's not just about temperature. It's not just that it gets warmer. It has impacts on agriculture. It has impacts on biodiversity, the living planet. It will have impact on our oceans. And of course, in the end, it will hit our economies. So I think we need to look at the whole span of the climate challenge. Now, what does it mean in terms of what we need to do? And this is just a graph from the Global Carbon Project. It's one of the most prominent, or the most prominent mapping of what we need to do at the global level. And just to summarize it very, very briefly, this is what we need to do. So this is the scope of the climate challenge. First of all, we need to decrease emissions by 50% every decade. So 50% the first decade, 50% the decade after that, etc., until 2050. And then some models would say, and some people would argue, we need to go carbon negative. So we need to find ways to actually start removing CO2 from the atmosphere if we are to stay within a safe 1.5, 2 degree climate change scenario. So that's one thing. So this is the scope of the challenge. The other thing, and don't forget it, is that if we are to solve the climate challenge, we need to steward what some people call the natural sinks on the planet, things as forests, the oceans, farming ecosystems, etc. These are part of the living planet that are, at the moment, are helping us to cope with CO2 emissions by removing it and providing other services. So it's not just about energy efficiency, it's also about making sure that we protect the living planet. And then the third point, which I think is important, and it's also included in this call when we think about the climate challenge, it's not just about removing or reducing emissions, it's also about thinking, how do we adapt to what is coming, because there will be climate change. The question is just how much, how do we adapt to it? And in some senses, when adaptation is not possible, how do we transform into something very different? And this can be at a community level, and it can be at an industry level. So think about these three things whenever we talk about the climate challenge. Now, the question is, of course, moving into a future with much more available data, with automation, etc. What does it mean when we discuss the climate challenge, and how do we deal with it? Of course, you've seen multiple think pieces. This is typical think piece in Forbes. How can we use AI to tackle climate change? Which I find interesting, but also very limiting. So there's a lot of discussion and hype around what are the potential for modeling, prediction, and efficiency. And I think that's just one way that we can think about it. I think we need to be more creative. I think we need to see the full span of things that we can do using AI. So I think AI will help us perceive and see what's happening in our environment, in the climate system, in societies in a different way. I think it will help us get better knowledge and see new patterns in these systems. I think it can help us respond to climate change, and I think it will help us innovate. And I'm going to give you a few examples. So this is really just a smorgasbord of things that are happening. It's not about promoting a particular company, but more what are the things that are low-hanging fruits where AI and the climate challenge are connected. So some direct benefits and low-hanging fruits. First of all, a lot of interest around this, of course. How can you use AI to use natural resources more effectively, like energy, water, pesticides, or design, for example. And of course, precision agriculture is being discussed. This is a massive industry, still growing. I see some risks, but it's very clear that there are some efficiency gains that you can do and make. Of course, with sensors and satellites, you get more data. You have faster and sharper and more predictive algorithms. And of course, what some call increased intelligent autonomy. So of course, yes, there is potential to use that in terms of increasing production and using resources in a more effective way. Another thing that I find a little bit more interesting and to think about that I recommend is the idea that you can use AI to design circular economy models. So it's both the design of a product, but it's also more efficient use of the infrastructure for circular business models. Like how do you make sure that you reduce waste, for example. So I would check it out. The Ellen MacArthur Foundation has a special node working on that. You can Google and find. Another thing that I find intriguing is that you can use AI to fill in data gaps. So there's a lot, when we think about the climate challenge, especially the social dimensions, we're missing a lot of data. When you miss data, it's difficult to prepare and to help people. There are some quite exciting examples of what you can do. In this particular case from Blumenstock in Science, they show how you can use satellite data and neural networks in a way that you can map poverty at the very fine scale, local, regional level in different ways that you couldn't do before. So essentially, you can just understand how a city is changing, what the income levels are likely to be, who's most vulnerable to climate change in the future, etc., at a much more effective and cheaper way compared to, for example, surveys. So that's happening now. Another thing that I think is important in terms of this, trying to get better data that you can act on. Another example is to use satellite data and artificial intelligence to try to redirect financial investments. So assume that you're a pension fund or you're a big investor and you want to see what impact your investment has on the ground on a particular company that you invest in, like how are CO2 emissions changing in that company over time. Normally, you would wait for that company to report that to you, and that's the idea behind something called the Spatial Finance Initiative. You can use satellite imagery and AI to get that data in real time immediately. So you're not dependent on biased data coming from that company, and you can redirect your money from something that is harmful, hopefully to something that is more regenerative and helps you solve the climate challenge. And it's not just about satellites and big money and big investors. I mean, there's another interesting example, the Rainforest Connection. You can find that online too. It's essentially how to use very simple technologies. In this particular case, what they use are recycled phones, and they use TensorFlow to analyze the soundscape. So the soundscape or rainforests, so you get both ecological data because you can hear certain species, but then you can also hear whether someone is logging illegally somewhere. And that data is analyzed and then submitted as warnings to agencies around the world. So just for you, good to know, tropical forests are very important sinks for carbon on the planet. So that's why this suits into the climate challenge. Another thing that we find interesting in terms of the science is that we're seeing AI, or in this particular case, deep learning, being used to improve models that help us see what's going to happen with the climate in the future. This is from one paper. And essentially what it does, it combines the conventional Earth system model or a climate model and then adds components that have a deep learning feature, and by that make these models much more sophisticated. So they help us narrow down possible climate futures. I find that very interesting. And a little bit more of a bottom-up case here is a hackathon that we did together with AI Innovation on using deep learning to automate ecological monitoring of common murre, which is a very important bird species in the Baltic. And by automating monitoring of that bird, you can say something about the changing state of the Baltic. So suddenly you get much more detailed, fine-grained data about how the Baltic and the biodiversity in the Baltic is changing as a result of human drivers like pollution, but also climate change. If you want an additional example of how you can use big data analytics combined with preparing for climate change in this context, the urban challenges and ecology, I would recommend the work by the Urban Systems Lab in New York. It's led by Dr. Timon McPherson. They're doing very, very interesting and very detailed work on how do you make sure that you use really good data, advanced algorithms to prepare for a turbulent climate future in urban systems. And I know that they're using part of those insights already now to help cities prepare for the COVID-19 pandemic by identifying vulnerable groups, where do they live, what's likely to happen if it gets too warm this summer, which parts of the city and which groups are vulnerable to that. So I highly recommend what they have done so far. So just to wrap this up a little bit, and of course there are lots and lots of issues and lots of problems as well in using AI for the climate challenge. I'm not going to talk too much about them. I'm going to focus more on the opportunities. And this is something that I've learned from my colleagues doing urban research. What they note is that we're moving into an urban opportunity. So more than 60% of the area projected to be urban in 2030 has yet to be built, which means that if we do it right, if we make sure that future cities are built in the right way, we can build them in a way that are much more climate resilient. And of course, linking to this call, we can also think about a climate resilience innovation opportunity. At the moment, we don't know. There are many, many possible ways that you can use AI to help deal with the climate challenge. So again, both the mitigation challenge, reducing emissions, but also helping us prepare and transform and build resilience into a more turbulent climate future. So there are lots and lots of opportunities. What could be done when this is up for grabs for everyone, and these has yet to be created. So there's massive potential. That's all I wanted to say. And I hope that you find something of interest here. So I wish you all good luck for the matchmaking, and thanks for AI Innovation for inviting me to share some thoughts on this.